Welcome to my channel where we learn for fun. Today we shall be learning how to use the Gauss-Siedel method to solve a system of equation. First, I'll give the Gauss-Siedel formula and then we will solve an example. Don't forget to like this video by hitting the red subscribe button down below. Drop a comment, and if you are new to my channel, please quickly hit the red subscribe button and click on the notification bell so that when I drop a new video you will be notified. Now, Gauss-Siedel method formula goes thus. Suppose we have three systems of equation: a1x plus b1y plus c1z equals to p as our first equation, and we have a2x plus b2y plus c2z, everything equals to q as our second equation, and then we have a3x plus b3y plus c3z to be equals to r as our third equation. And we want to use the Gauss-Siedel method to solve this system of equation. Now, before we proceed, let me quickly explain this, that the x, y and the z are the variables, while the a1, b1, c1, a2, b2, c2, a3, b3, c3 are the constants or the coefficients of this variable, and the p, q and r are the solution to each of these equations. So to solve using Gauss-Siedel method, we need to use each of this system to solve for each of the variables. So we will use equation 1 for x, equation 2 for y, and equation 3 for z. But the first thing we need to check is the diagonal row dominance form. We want to check and make sure that the absolute value of a1 is greater than the addition of the absolute value of b1 plus the absolute value of c1. And then we also want to check that b2, the absolute value of b2 is greater than the addition of absolute value of a2 plus absolute value of c2. And then for the last equation, the absolute value of c3 must be greater than the absolute value of a3 plus the absolute value of b3. So you see, we check a1, b2 and c3. The diagonal of this system of equation must have the diagonal row dominance form. So when we check this and this is true, then we can proceed to the iterations, and the iterations, it will give us this to get the solution to each of these variables, or this for the variables using iterations. We're going to be using, for equation 1, to solve for x, we'll say x will be equal to p. We're using equation 1, p. We move these two values over here to say p minus, remember this will change onto minus, but as they cross the equation sign, minus b1y minus c1z divided by the coefficient of x, which is a1, and that will give us the solution for x. For y, we will have q minus a2x. Remember, we're solving for y here. a2x plus c2z divided by the coefficient of y, which is b2, is a1, and then for z we have it to be equals to r from equation 3 minus a3x, which is this, minus b3y divided by the coefficient of z, which is c3. And these are the formula we are going to be applying in order to solve for each of the variables. So we keep solving in iterations. We keep solving an iteration, inserting the new values into the next iteration in order for us to achieve the next value of the variables, until we get to such a point where the variables are no longer changing and we say we have reached a point of convergence. So let's quickly see an example. So we have this example: solve the system of equations using Gauss-Siedel method. 4x plus y minus z is equals to 3. 2x plus 7y plus z is equals to 19. X minus 3y plus 12z is equals to 31. And we are given initial values for x, y, and z to be 0, 0, 0. So we proceed using the formulas that we have created for each of them. So we have iteration 1 first, iteration, iteration. So we say for x is going to be equals to 3 minus y plus z divided by 4. Remember, our x, our y and z are 0, 0 because this is x, y, z. We have initial guess to be 0, 0. So y is 0 here, z is 0 here. So this simply gives us a simple solution, because 3 minus 0 plus 0 is still 3. 3 over 4. And that gives us equals to 0.75. That is our first value for x. We go on to y. For y, we say the formula for y is 19. Now we use x, 19 minus 2. Now instead of writing x, I just put in the value for x, which is 0.75. I'm not going to be using z because I have a new value for x that I'm going to be using immediately. 0.75 plus that will be minus z, which is still 0. Z is still 0 because we have not calculated a new value for z. So divided by 7, the coefficient of y, and this will give us 19 minus 1.5 divided by 7. Here we will have 17.5 divided by 7, and this should give us 2.5. So we have a new value for y. Then we proceed straight to z, where we have, for z we have 31 minus 0.75, which is the value for x, 0.75 plus 3y plus 3 into 2.5 divided by the coefficient of z here is 12, and this will give us 31 minus 0.75 plus 3 into 3 multiplied by 2.5 will give us 7.5 divided by 12. When you sum all of this up, you have 37.75 divided by 12, and this will give us 3.15. So we have new values for our variables. So x, y, z are now equal to x is 0.75, y is 2.5, and z is 3.15. And we are done with the first iteration. For the second iteration, we need to now plug in these new values into the formulas again. So for x, we have 3 minus y, which is 2.5, minus 2.5 plus z, which is 3.15. Remember, 2.5 and 3.15 are the same values that we got, in our first iteration. So we are just plugging them back into the second iteration. So divided by 4. Divided by 4. And this here will give me 3.65 divided by 4. And I have my new value for y, for x, is 0.91. For the new value of y is going to be equals to 19 minus 2 into, now x, I have a new value for x, which is 0.91. So I'm not going to be using the previous value of 0.75, but I'm going to be using the new value of 0.91 minus z, which I have the value 3.15. Divided by the coefficient of y, which is 7. So when I multiply this out, I have 19 minus 1.82 minus 3.15, which is this, divided by 7. And doing this arithmetic, I have 14.03 over 7, and this will give me 2.00. That is the new value for y. So for the new value for z, I have 31 minus 0.91, which is the value of x, 0.91 plus 3 into 2, the new value for y, okay, divided by 12, and this will give me 31 minus 0.91 plus 6 divided by 12. Alright, and doing this arithmetic, I have 36.09 divided by 12, and this will give me 3.00. 3.01. So my new value for x, y, and z have now become 0.91, 2.00, and 3.01. And that leads me, that's the end of iteration 2, second iteration. I go straight for the third iteration. The third iteration. Now notice this is 0.91, 2.0, and 3.01. So we're going to check by the third iteration. If this value remains the same, then we will say we have reached the point of convergence. Of my markers. Okay, for the third iteration for x, I'm going to be having 3 minus 2, which is the value for y, plus 3.01, which is the value for z, divided by 4, the coefficient of x. So, and this will give me 4.01 divided by 4, and of course that will give me 1. For y, I have 19 minus 2 into the new value of x is 1 now. I'm not going to be using 0.91 anymore. I'm going to be using the new value of 1 minus 3.01. I'm still using the old value of z because there is no new value for z, divided by 7. And this arithmetic will give me 13.99 divided by 7. Watch, this is approximately 14 divided by 7, and this will give me 1.99, approximately 2. For z, I have 31 minus 1 plus 3 into 1.99 divided by 12, and this will give me, doing this arithmetic, I have 35.97 divided by 12, and this will give me 3. So the new value for x, y, z is now 1, 1.99, and 3. So since I have these two to be whole numbers, I can approximate this to also be whole numbers. So this is approximately 2. So I have x to be 1, y to be 2, and z to be 3. And since I have the same answer, the same very close solutions in the second and the third iteration, I can stop in the fourth in this iteration to say my solution now becomes x is equals to 1, y is equals to 2, and z is equal to 3. Now we're going to quickly do a check on this solution in the original equation. So from the first equation, I'm going to check if these values are true and correct. So I have 4x plus y minus z equals 3. So if I substitute all of this value here, am I going to get 3? Yes, I'm going to get 3, because if I say 4 into 1 plus y is now 2 minus z is now 3, what will I have? I have 4 multiplied by 1 will give me 4 plus 2 minus 3. So 2 minus 3, or let me see, 4 minus plus 2 is 6. 6 minus 3 is going to give me a 3. And my solution pans out correct. For the second equation, I have 2x plus 7y plus z to be equals to 19. So here my x is 1, so I have 2 into the bracket of 1 plus y is 2, 7 into the bracket of 14, of 2 plus z is 3. So this is 2 times 1 to give me 2, 7 times 2 to give me 14 plus 3. So 2 plus 14 is 16 plus 3 is equals to 19. And my second equation also pans out. So these solutions are true for these two equations. Now I need to check for the third equation to see. We have x minus 3y, yes, 3y plus 12z equals 31. And here we have x is 1 minus 3 into the bracket of 2 plus 12 into the bracket of 3. So I have 1 minus 6 plus 36. For the sake of simplicity, I may like to turn this around to see 1, take this here, I'll do this minus here, plus 36 minus 6. So this is 37 minus 6, which is equals to 31. And my third equation also pans out. So my solution to this system of equation is actually true and correct, that x is 1, y is 2, and z is 3. So that is the solution to our system of equation. So we have learned how to use Gauss-Siedel method to solve a system of equation performing iterations. Thank you very much. So if you have enjoyed this lesson, and I enjoin you to give this video a thumbs up. You have drop a comment in the comment section below, and make sure, if you are new in this channel, please hit the subscribe button. Encourage us with all of these simple gestures, and thank you.